Hello everyone, welcome back. In this session, we are going to look at one example for the optimal binary search tree and solve a problem using the recurrence for the OBST. So here is the recurrence where we have I and j which are between 1 and n. We have items from 1 to n, and we have to find the minimum for this r between I and j, and which is summation of the probabilities from I to j plus the cost of left subtree and the cost of right subtree. There is a boundary condition which says if I is greater than r minus 1, then this is 0, and if r plus 1 is greater than j, then this is 0. So how we are going to go about it is we go by the diagonal, fill in the diagonals, and because of our boundary conditions, the values below the diagonal are going to be 0, and we are going to calculate values above the diagonal in this way. And as we fill the cost of these minimum values in this grid, we are going to fill the root values in the RJ grid. We will see as we go. So first of all, we are going to fill the diagonals. So going from 1 to 1, or the cost of item 1 to 1 is going to be its probability. So this is going to be 40. So we are going to fill the diagonals with the probabilities of the items. So then 2 and 2 is going to be 30, 3 and 3 is going to be 10, and 4 and 4 is going to be 20. Similarly, for the roots, these are going to be 1, 2, 3, and 4. And values below are going to be 0. Now, we have to fill this way. So then this means we are going to find values 1, 2, then 2, 3, then 3, 4. After that 1, 3. After that 2, 4, and then 1, 4. So let's start with the first one. So when we are going to do 1, 2, this means I is equal to 1 and j is equal to 2, right? And we are going to find C I j which will be minimum of all the values of r, which are r is equal to I to j, which is 1 to 2. So then r is going to be 1 and r is going to be 2. So if we look at our recurrence, It says probability of going from I to j, and we are going to do the summation. So I to j is 1 to 2, which means sum of probabilities 1 to 2. So then sum of probabilities from 1 to 2 is 40 plus 30 is 70 plus cost of I, which is 1, and cost of I and r minus 1. R is 1, 1 minus 1 is 0, plus cost of r plus 1, which is 1 plus 1, 2, and cost of j is 2. This is 70. And here I is greater than r minus 1. So we have our first boundary condition, which is 0, plus cost of 2 and 2, which is 30. So then this is 100. Similarly, when r is equal to 2, the cost of probability, the summation of probability from I to j is going to remain same, which is 70, plus cost of I is 1, r minus 1, 2 minus 1 is 1, plus cost of r plus 1, r plus 1 is 3, and j is 2. So then this is 70 plus 40 plus, because r plus 1 is greater than j, our second boundary condition is hit, which is 0. So then this is 0. So we have the minimum value equal to 100. This means Cij, which is 1, 2, is going to be 100, and we have picked r is equal to 1, which means item 1, and we are going to put 1 in cell 1, 2. Okay. Now the next value we have to find is cost of 2, 3. So when cost of 2, 3, this means I is equal to 2 and j is equal to 3, and cost of ij will be minimum r is equal to 2 to 3, then r is equal to 2 and r is equal to 3. So for summation of probabilities from 2 to 3 is 30 plus 10, which is 40, plus cost of I, r minus 1, cost of I, which is I is 2 and r is 2, 2 minus 1 is 1, plus cost of r plus 1, which is 3, and j is 3. So plus, because our first condition is hit, I is greater than r minus 1, so this is 0, plus C33, C33 is 10, this is 50. Similarly, for this, cost of probabilities, summation of probabilities, again I to j, which is 2 to 3, 2 to 3 is 40. So this is going to remain same, and then this will come out to be C22 plus C43, which is 40 plus 30 plus boundary condition, which is 70. So cost of 2, 3 is minimum of these, which is 50. So we are going to put 2, 3, 50. And because we chose r is equal to 2, so the root item is 2. So 2, 3 is 2. Okay. Now what exactly are we doing here? what we are doing here is we are taking out all the different combinations for R, which can be between values I and j, as we saw in our previous session. So for example, if R is between 1 and 2, this means we are trying to find all the combinations of item 1 and 2. So item 1 and 2 can be, item 1 and 2 is 10 and 20. So it could be like this, or it could be like this. Now what will be the cost? Frequency of 10 is 40. So 0.4 into search time is 1, and frequency of 20 is 30, which is 0.3 into cost is 2. So this will come out to be 100 or 1.00, right? Similarly, for this, the probability is 0.3 and the search cost is 1. The probability is 0.4 and search cost is 2. So this will come out to be 1.0. And that's what we got here. So which one is better? This one is better, which means when root is 10 and its child is 20, our tree is more optimized. And that's what we did. We picked 100 and 10 is item 1, which is, we picked item 1 here. Okay. Similarly, we did here when we have item 2 and 3. So when item 2 and 3, it could be 20 and 30, or it could be 30 and 20. So when root is item 2, our cost was 50, and when root is item 3, which is 30, our cost is 70, and we picked 50, and we say item 2 is going to be the root when we are talking about item 2 and 3. Similarly, we are going to find all the possible combinations and building a grid. So now next is 3, 4. So when I is equal to 3 and j is equal to 4, we are going to find cost of ij, which is r going from 3 to 4, and r is 3 and r is 4. So summation of probabilities of item 3 to 4 is 10 plus 20, which is 30. So 30 plus cost of 3 to plus cost of 4, 4, which is 3. This is boundary condition, and 4, 4 is 20. So this came out to be 50. Similarly, this came out to be cost of I is 3 and r minus 1. 4 minus 1 is 3 plus r plus 1. R plus 1 is 4 plus 1, 5, and j is 4. So then this is 30 plus 10 plus, this is boundary condition because r plus 1 is greater than j. So this will be, and we get 50 and 40. This is minimum. So we are going to pick r equal to 4 for cost of 3, 4. So cost of 3, 4 came out to be 40, and we picked item 4 here. Now next is 1, 3. Cost of 1, 3. So I is 3. Cost of 1, 3, which is I is equal to 3 and j is equal to I is equal to 1 and j is equal to 3. So our cost ij is equal to minimum of 1 to 3, which means our R is going to be R is equal to 1, R is equal to 2, and R is equal to 3. So summation of probabilities from 1 to 3. 1 to 3 is 40, 30, and 10, which is 80. So this is 80 plus cost of I is 1 and R minus 1 is 0 plus cost of R plus 1, 2 and j is 3, which is 80 plus this is boundary condition and this is 50, which is 130. Similarly, this will be 80 plus 40 plus 10, which is equal to 130, and this will be 80 plus cost of I1 and 2 plus cost of 4 and j is 3. So this is, and 1 2 is 100 and this is 0, which is 180. So we have a tie. Let's say we are going to pick item 2. So I13, cost of 13 is 130. Cost of 13 is 130 and we picked item 2. Okay. Now next is cost of 24. So then I is equal to 2 and j is equal to 4. So cost of ij is equal to minimum of r is equal to 2 to 4. So then r can be 2, r can be 3, r can be 4. Summation of probabilities from 2 to 4. 2 to 4 is 30, 40, and 60. Plus cost of 2, 1 plus cost of 3, 4, which is 60 plus boundary condition plus 40 is equal to 100. Similarly, this will be summation of probabilities from 2 to 4 is 60 plus cost of 2, 2 plus cost of 4, 4, which is 60 plus 30 plus 20 is equal to 110. Similarly, this one is 60 plus cost of 2, 3 plus cost of r plus 1, which is 5 and j is 4. So 60 plus 50 plus boundary condition r plus 1 is greater than j, so this will be 0 and this is 110. So we have minimum value of 100, which is r2. So c cost of 2, 4 is 100. Cost of 2, 4 is 100 and we picked item for 2, 4. And now we are going to calculate the last one, which is 1, 4. So cost of 1, 4, which means I is equal to 1 and j is equal to 4. So cost of I, j is minimum of r equal to 1 to 4. R can be 1, R can be 2, R can be 3, R can be 4. Okay. Now summation of probabilities from 1 to 4 is 40 plus 30 plus 10, which is 80, and 20, which is 100. So 100 plus cost of I 1 and R minus 1 is 0 plus cost of 2 4, which is 100 plus boundary condition plus 2 4. 2 4 is 100. 2 4 is 100. Let's see. 2 4 is 100. So this is 200. Similarly, cost of probability, summation of probabilities from 1 to 4 is 100, which is going to remain same, plus C11 plus C34, which is 100 plus 40 plus 40 is equal to 180, and this one is 100 plus cost of 1 2 plus cost of 4 4, which is 100 plus 100 plus 20, which is 220, and this is 100 plus cost of I is 1 and R minus 1 is 3 plus cost of R plus 1 is 5 and J is 4, which is 100 plus 1 3 is 130 plus 5 4 is boundary condition. So this came out to be 230. So out of this is the minimum, item 2. So we are going to put 180 here and item 2 here. Okay. So then this means our optimal binary tree cost is going to be, optimal cost of tree will be 180. And how this tree is going to build is, so we have a tree which has items 1 to 4. Okay, so 1 to 4. This means we are going to look at 1 to 4 here. And what is the value at 4? Which is item 2. This means item 2 is going to be the root when we talk about items from 1 to 4. So 2 is the root, and on the left we are going to have items which are less than 2, which is actually 1, and on the right we will have items which are greater than 2, which are 3 to 4. Okay. So now, because this is a single value, we don't have to do anything with it. But with 3 and 4, we need to find out which is the root between 3 and 4. So we look at 3 and 4 and we see that 4 is the root, the top value. So then if 4 is the root, so we get 2, 1, 4 is the root between 3 and 4. Now if 4 is the root, then 3 is going to come here. And this is our final optimal tree. Now if we want to put values instead of items, we can do that. And let's calculate. So 20's probability is 30, which is 0.3 into 1. Probability of 10 is 0.4 and search time is 2. Probability of 40 is 0.2 and search time is 2. Probability of 30 is 10. So 0.1 and its search time is 3. So if we calculate all these, this comes out to be 0.3 plus 0.8 plus 0.4 plus 0.3, which is 11 and 7, 1.80, or the cost is 180, which actually matches our cost. So that's how we are going to calculate a optimal binary search tree when we are given items and their probabilities. So this was a very detailed example where we used the recurrence to fill the grid of costs and the root values, and finally filled the grid for these values and were able to find the optimal binary search tree and the cost of this tree. I hope this example was informative for you and you were able to understand how to solve an optimal binary search tree problem using the recurrence. I'm going to end this session here, and we'll see you in our other dynamic programming sessions. Thanks for watching, and bye for now.